Hello mga ka-tribes! Welcome to Daddy Brood TV. For today's video, let's have lesson 3, Variance and standard deviation of a discrete random variable. For our objectives, let us illustrate the mean and variance of a discrete random variable. And let us calculate the mean and the variance of a discrete random variable. So, what's in? To start our presentation, let's define the variance of a random variable x. The variance of a random variable, capital letter X, is denoted by small letter sigma squared. It can also be written as var of x. The variance of a random variable is the expected value of the square of the difference between the assumed value of a random variable and the mean. In short, the formula is var of x is equal to the summation of the quantity x minus mu squared times p of x, or sigma squared is equal to the summation of the quantity x minus mu squared times p of x, where x is equal to the outcome, mu is the population mean, and p of x is the probability of the outcome. Of course, the standard deviation, sigma, is simply the square root of the variance. Before we have an example, for uniformity of the answers, expected value or mean and standard deviation are both expressed into 2 decimal places, while variance is up to 4 decimal places to lessen the rounding error. Now, let's have example 1. Solve the variance and standard deviation of the following probability mass function. Given the table, the random variable x are 1, 2, 3, 4, 5, and 6, whose probability are 0.15, 0.25, 0.30, 0.15, 0.10, and 0.05. Now, first step, to find the expected value, let's make a 3 columns. First column for the random variable x, second column for the probability of the random variable x, and the third column is the product of the random variable and its probability. So, to get 0.15, just simply multiply 1 and 0.15, that is 0.15. 2 times 0.25 is 0.50, 3 times 0.30 is 0.90, 4 times 0.15 is 0.60, 5 times 0.10 is 0.50, and 6 times 0.05 is 0.30. Adding these products, we have now the summation of x times p of x, or simply the expected value, which is equal now to 2.95. Take note, finding the variance and the standard deviation, do not forget to find the expected value first, or the mean, because the mean is very important. Okay? Now, for the second step, let's subtract e of x, or the mean or the expected value, from each outcome, and then let's square each difference. So let's continue adding fourth column. We have the x minus mu. X here are 1, 2, 3, 4, 5, 6. Subtract it to your expected value. So that is 1 minus the expected value, which is now equal to negative 1.95. 2 minus the expected value, that is now negative 0.95. 3 times the expected value, that is now 0.5. 4 minus the expected value, that is now 1.05. 5 minus the expected value, that is 2.05. And 6 minus the expected value, that is now 3.05. Then, let's add again another column, which is our quantity x minus mu squared, meaning we are going to square these values. Okay, so the square of negative 1.95 is 3.8025. Square of negative 0.95 is 0.9025. The square of 0.05 is 0.0025. The square of 1.05 is 1.1025. The square of 2.05 is 4.2025. The square of 3.05 is 9.3025. And for our third step, let us add again our sixth column, wherein our sixth column is the product of the quantity x minus mu squared and p of x. Okay, for step 3, let's multiply each squared difference by the corresponding probability. The probability is the p of x. So just simply multiply the quantity x minus mu squared to p of x. So 0.15 times 3.8025 is 0.570375. 0.25 times 0.9025 is 0.225625. 0.30 times 0.0025, that is now 0.00075. 0.15 times 1.1025 is equal to 0.165375. And 0.10 times 4.2025, that is now equal to 0.420250. And 0.05 times 9.3025 is equal now to 0.465125. Okay, for our fourth step, sum up all the figures obtained in step 3. So meaning we are going to add all this data or figures. So the summation now of the quantity x minus mu squared times p of x is equal to 1.8475. So therefore, our expected value or mean is 2.95. Our variance or var of x or small letter sigma squared is equal to 1.8475, or as we agreed, that is 1.85. And whose standard deviation, just simply get the square root, that is now equal to 1.359227 or 1.36, 2 decimal. Okay, let's have additional example. Let us read and analyze the situation given below. Mr. O'Malley, a mathematics teacher, regularly gives a formative assessment composed of 5 multiple choice items. After the assessment, he used to check the probability distribution of the correct responses, and the data is presented below. Now, our random variable x are the test items 0, 1, 2, 3, 4, 5, and the probability are 0, 3, 0.05, 0.12, 0.30, 0.28. Okay? Now, for our solution, again, given the 2 columns, let's add the third, fourth, fifth, and sixth column. For the third column is simply the product of x and x. That's now 0 times 0.03 is 0. 1 times 0.05 is 0.05. 2 times 0.12 is 0.24. 3 times 0.30 is 0.90. 4 times 0.28 is 1.12. And 5 times 0.22 is 1.10. Summing this up, we have now the expected value, or equal now to the mu sub x, which is equal to 3.41. 3.41 is our mean or the expected value. Next column, we will subtract our x to our mean. So the 0 minus mean is negative 3.41. 1 minus the mean, that is negative 2.41. 2 minus the mean, that is negative 1.41. 3 times the mean, that is now negative 0.41. 4 minus the mean, that is now 0.59. and 5 minus the mean, that is now 1.59. And then, let's square. By adding the fifth column, let's square this. So the square of negative 3.41 is positive 11.6281. The square of negative 2.41 is positive 5.8881. The square of negative 1.41 is positive 1.9881. The square of negative 0.41 is 0.1681. The square of 59 or 0.59 is 0.3481. The square of 1.59 is equal to the positive 2.5281. Then for our sixth column, let's multiply this square to our P of x. So 0.03 times 11.6281, that is now 0.3488. 0.05 times 5.8081, that is equal to 0.2904. 0.12 times 1.9881, that is equal to 0.2386. 0.30 times 0.1681, that is now 0.0504. 0.28 times 0.3481, that is 0.0975. 0.22 times 2.5281, that is now equal to 0.5562. Adding this, we have now equal to the summation of the quantity x minus u squared times p of x, which is equal to 1.5819. We can also do this process, no? We will shorten our solution, no? Okay, to get the variance or the sigma squared sub x is equal to the summation of the quantity x minus mu squared times p of x. So just simply, our first data or random variable is 0 minus the mean 3.41 squared times the p of x, the probability, plus the second value 1 minus 3.41 squared times the probability 0.05, plus the third value, which is 2 minus the mean 3.41 squared times the probability is 0.12, plus 3 minus 3.41 squared times the probability 0.30, plus 4 minus 3.41 squared times the probability 0.28, and plus 5 minus 3.41 squared times the probability 0.22. Therefore, the variance or sigma squared is equal to 1.58, which is equal to our previous solution. So since the variance is 1.5819 and the standard deviation is simply the square root of 1.5819, and it is equivalent to sigma is equal to 1.26. Therefore, the correct answer for question 4 are 1.5819 and 1.26 respectively. Thank you for watching. See you on my next video. Bye.